Welcome to ChemPlus. Welcome to ChemPlus. Today we've decided to make a standard solution of sodium hydrogen carbonate. What equipment we need? Let's go. We are going to need a 250 ml volumetric flask. We are going to need a balance. We are going to need a weighing board. We're going to need a beaker. We are going to need distilled water, and we are going to need a glass rod. A standard solution is one whose concentration is known. We should not lose sight of that. A standard solution is one whose concentration is known exactly. When you measure the volume in your volumetric flask, you should make sure that your distilled water gets to the to that line there. That's where the 250 mark is, and you should measure the volume of liquids at the meniscus. This is the meniscus, and you aim to measure from the bottom of the meniscus. A standard solution is one whose concentration is known. So that's the purpose of this practical. We are going to work out the concentration of sodium hydrogen carbonate. Now then, when I've carried out this experiment with one of my classes, their mass of the bot was 0.55. Mass of bot plus solid was 2.55 grams. Therefore, we can work out the mass of the solid, which was 2 grams. Let's go. How do we work out the concentration of the sodium hydrogen carbonate? To begin with, let's work out the MR of the sodium hydrogen carbonate. Let's work out the MR, which is sodium plus hydrogen plus carbon plus 3 oxygens and that gives us 84. That's the MR. Now the next big thing that we want to do is to work out the number of moles of sodium hydrogen carbonate. Sodium hydrogen carbonate is equal to mass over Mr, which is equal to 2 grams divided by 84. You need your calculator. 2 divided by 84 and you get 0.0238. It's a long number going. It's a long number. Don't make those. The moles are at the bottom there going. It's a long number going. Now that we have the moles, we can now work out the concentration. We know that moles is equal to C times V over 1,000. Therefore concentration, I want to pick a bigger. Therefore concentration is equal to moles divided by volume over 1,000. Now, which is equal to, your moles is 0.0238. Divide by volume, which is 250. That's our volume over 1,000. Now you're going to punch that in now. My handwriting there is not really good. That's 238 there. Let me pick a better pen. 238. So when I've divided that, I am getting let me do it again, 0.0238 divided by open brackets 250 divided by 1,000. I am getting 0.0952 more decimeter, which means our concentration for this solution is 0.095 more decimeter. A standard solution is one whose concentration is known exactly. Now we know the concentration of this sodium hydrogen carbonate. We know the concentration of this sodium hydrogen carbonate. You should be able to do this practical in the lab without any big problems, right? We hope you've learned a bit on making standard solutions. Signing out from inside the cup. King of the classroom. Bye bye.